Good day to you out there. I want to do the naming of type of inorganic compound called the Tertiary or Quaternary compounds. You should agree with me that in the earlier class, when I do the naming of the binary compounds, I told you that the inorganic compounds, when you want to do the naming of inorganic compounds, we have two forms of doing the naming. We have the category set of compounds that are put in the as binary compounds, and we have another set of compounds that are put in the category of the tertiary or quaternary compounds. Now, the following set of compounds are found under the tertiary or quaternary compounds. They are 1. The oxo acid, 2. Acid radicals, 3. Salt, which can either be normal salt or acidic salt. We have the bases and the basic salt. We also have the one we call the complex salt and complex ion. These are the forms of compounds that we have under the naming that falls under the tertiary or quaternary compounds. In this video, I'm going to deal with how do we do the naming of the oxo acid. Now, oxo acid, as the name implies, if you look at the name very well, you will see that we have oxo there and we have the acid there. The oxo there means that that particular compound contains oxygen. When a compound contains oxygen, it means that that particular set of oxygen is mixed with a particular compound that makes it all to become what is called an acid. Another thing to take note of in that kind of a compound is that any compound that is called an acid, it means that there must be inclusive of a particular atom there, which is hydrogen. The hydrogen is also inclusive in that part of atom there. Let's now look at how we are going to do the naming of the oxo acid. In the naming of the oxo acid, the following set of rules you must follow appropriately, which is very simple. Number one thing there is this. Look at the number of oxygen that we have there. Then you indicate and you put at the prefix position the number of oxygen in Greek words, such as when you have 2, it's going to be called di. 3, oxygen will be called tri. 4, tetra. 5, penta. 6, hexa. 7, hecta, and so on like that. That is how you are going to put at the prefix in the naming of number of oxygen that you have there. Don't forget, I have told you that when you have an oxo acid, it means that that particular compound contains oxygen, and there must be an inclusive of what? Hydrogen, which that hydrogen will be the one that's going to show us that particular compound is an acid. Now, after the naming of number of oxygen that you have there, another thing you are going to take note there is this. There's going to be a particular atom that are going to present as, and it will be regarded to as the central atom. This central atom can either be a metal or non-metal. Then, that central atom will be named next after you have put the number of oxygen in Greek word, and you call the oxygen there. You don't call it oxygen straight away like that. You call it oxo. For instance, if I have 4 oxygen, I will call it tetraoxo. Then it will be followed by what? The naming of the central metal or central non-metal atom. If such an atom, for instance, if it is a nitrogen, for instance now, you will call it nitrate. Take note of what I did there. Which means that for every central atom that's going to be in oxo acid, their name will end with ATE. Instead of the name to end with normal naming, for instance, nitrogen, for example, now we are going to call it nitrate instead of nitrogen. You name it as nitrate. Then you now calculate. That's the next thing you have to do there. You will calculate the oxidation number of such central metal or non-metal atom. Then if you calculate the oxidation number, you put it in Roman numeral into bracket, then you end the name with acid. since we are going to have hydrogen there. Don't forget that putting the name of the hydrogen does not even show here. So I'm going to show you some examples now on how we can name the oxo acid. For example, if I have this kind of compound, H2SO3. H2SO3. Now, if you look at this very well, as I have told you earlier, I said the first thing you do here is to name the number of oxygen there using the prefix as a Greek word. Then we have how many oxygen here? 3 oxygen. That's going to be what? Trioxo. Let me put the name here. Trioxo. So I have indicated the number of oxygen by showing that it is 3 oxygen here now. Trioxo. Then I told you that the next naming will be what? Will be the naming of the central metal or non-metal central atom. I refer to it E. The central atom here is sulfur, and it's going to end with what? It's going to be called sulfate. Sulfate. Then I finish naming the next line here. Sulfate. Then don't forget, I have told you that you are going to calculate the number of the oxygen number of this central atom. So I'm going to calculate the oxygen number of this sulfur here now. So I'm going to have, in the compound state, the oxygen number of hydrogen is 1 and plus 1, for instance. And that of oxygen is minus 2 in the compound state like this. So I'm going to have 1 times 2, that is 2 hydrogen here, plus sulfur, that is what I want to calculate its oxidation number, plus minus 2 times 3 is equal to 0. Don't forget that when you are trying to find the oxidation number of a particular element, the summation of a compound at the neutral level like this is going to be equal to 0. If you sum up all the oxygen number together, it will be equal to 0 because this is a neutral compound. Then I have it as 2 plus sulfur. Plus times minus is going to be what? Minus 6 is equal to 0. 2 minus 6, that's what? S minus 4 is equal to 0, where S will be equal to plus 4. So this one will be, the name will now be completed as triazo sulfate 4, put it in bracket, acid. Triazo sulfate 4 acid. I'm going to give you another one now. By the time I'm going to give you like 2 or 3 examples now, you should be able to do the naming of any forms of oxo acid with ease. H3PO4, that's another one. Now, looking at this very well, you would agree with me that you have oxygen here and you have hydrogen here. So it is obvious that this kind of a compound is an acid. The central atom we have here is phosphorus. Don't forget that the name will be changed and the particular element will be end with ATE. So we are going to have this one to be tetraoxo. That is the number of oxygen that we have here. Tetraoxo. Then we have the central atom, which is phosphorus, to be now be changed to what? Phosphate. Phosphate. Then you calculate the oxidation number of this phosphorus. Let's quickly do that here. That is, we have 3 hydrogen, that's 3. That's 1 times 3 is 3. Plus phosphorus. Plus, then we have oxygen number of oxygen in this compound state is minus 2. Minus 2 times 4, that's minus 8 is equal to 0. So that will be what? 3 minus 8, that is 5. P minus 5 is equal to 0. That's P is equal to plus 5. So this will be what? Phosphate 5 acid. Tetraoxo phosphate 5 acid. That is the name of this kind of a compound that we have here right now. So I'm going to give you another example now. Now another example that I can give you here is this. H2Cr2O7. Now, you will see that definitely we have oxygen here and we also have hydrogen. So this is a very good example of oxo acid as well. Now, we are going to name the number of oxygen, which is 7 oxygen. That is going to be hepta. This will be hepta oxo. Then the central atom. The central atom we have there is 2. You can see there, Cr2. So we call it di. This is chromium. We call it dichromate. dichromate, put the hyphen here, said tetraoxo dichromate. Then you have to calculate the oxidation number of this chromium here. So we have 2, that is hydrogen, multiply 1 times 2, that is 2, plus chromium, this is 2Cr, because we are having 2 chromium here, plus this is oxygen is minus 2 times 7, that's minus 14, is equal to 0. The summation of all the oxidation number of a neutral compound like this is equal to 0. Then we have it to be 2 plus 2Cr minus 14 equal to 0. So we have it to be 2 minus 14, that will be 2Cr minus 12 is equal to 0. So we have 2Cr is equal to plus 12, because when you have this one come to the side, it becomes positive 12. Then we are having Cr will be equal to 12 over 2, which is equal to 6. So then this name will be heptaoxo dichromate 6 acid. You can see that the name of the hydrogen doesn't show, but just to indicate that there is acid there, you put the H, you call it acid, that is the H that shows that there's an hydrogen that is in that compound. Now, let me look at what we are going to have again. We have another compound, which everybody are very familiar with, H2SO4. So look at this naming. We are going to name this as, how many oxygen do you have there? Tetra. That is 4 oxygen. That is tetra in the Greek word. Then now we have the oxygen, oxo. Then we have the central atom, which is the sulfur. That is going to be sulfate. Then you have to calculate the oxidation number of this sulfur here now. So let me do the calculation here. That is 2. That is hydrogen. 1 times 2 is 2. Plus sulfur, that is 1 of it. Then oxygen is minus 2 times 4 is minus 8, equal to 0. All the summation or addition of all the oxidation number must be equal to 0 of any compound in their neutral state. Then you have 2 minus 8, that is minus 6. X will be equal to plus 6. So tetraoxo sulfate 6. That is the oxidation number of this central atom. Sulfate 6 acid. That is how the name is derived. So those students are very familiar with this particular compound very well. When you see them, if you give any student what is H2SO4, they will tell you tetraoxo of the 6 acid. This is how the name is derived.